Okay, so what if I told you our best, most solid theory of physics actually predicts a type of star, a star that runs on a fuel so extreme it seems like it just shouldn't exist? We're talking about something that literally burns the fabric of matter itself. Today, we're diving deep into one of the coolest what-ifs in all of astrophysics, the completely theoretical and totally inviolable Electroweak Star.
So here's the game plan. First, we're going to break down what these bizarre objects are even supposed to be, and why they might be the universe's ultimate fuel source. Then we'll hit the two massive problems: why we could probably never see them, and, more importantly, why they probably can't even form to begin with. And finally, we'll talk about what it means when a really elegant theory on paper just doesn't seem to have a place in our reality.
All right, let's get right into it. What in the world is an Electroweak star? Now, this is not your typical star. We're talking about physics being pushed to its absolute, most mind-bending extreme.
Yeah, this is nothing like our sun, which, runs on nuclear fusion. An Electroweak star would be powered by something way, way more fundamental. Its core would be crushed by gravity so intensely that it actually triggers one of the universe's fundamental forces, the electroweak force. And this force would burn quarks, the building blocks of protons and neutrons, and convert them directly into lighter particles called leptons, like electrons and neutrinos. It's not fusion, it's the direct conversion of matter. To make something like that happen, you'd need a temperature that is, well, it's pretty much impossible to wrap your head around. 10 to the power of 15 Kelvin. That's a 1 with 15 zeros after it, a quadrillion degrees. To put that in perspective, this is hotter than the entire universe was just moments after the Big Bang.
And to get that kind of heat, you need density that is just off the charts. I want you to picture a core, no bigger than an apple, but it's been crushed by gravity so much that it contains the mass of 2 whole Earths. That is the unbelievable environment we're talking about, at the heart of one of these things.
When you look at the stats on paper, they almost seem reasonable. The mass is about the same as a neutron star. It's got a radius of about 8 kilometers, and it could theoretically live for around 10 million years. It had this outer layer of normal matter, protons and neutrons, but deep down in that electroweak core, that's where the truly wild, impossible physics is supposed to be happening.
So you have to ask yourself, after all that extreme physics, why would the universe even bother making an object like this? Well, the theory says it would be the absolute, final, end-of-the-line stage of energy generation, the ultimate cosmic fuel.
And to see where it fits, just think about how stars work, right? You've got normal stars burning through nuclear fusion. When they run out of gas, they can collapse into neutron stars. Now, those aren't really burning anymore. They're just held up by a quantum force called degeneracy pressure. The Electroweak star suggests there's a whole new step after that, a final, blazing stage where the star is powered by the direct burning of quarks.
And here's the real kicker. This isn't some crazy idea that needs us to invent new particles or brand new forces. Nope. This is a pure prediction straight from the standard model of particle physics. Our current, tested, confirmed rulebook for how the universe works. The recipe for this ultimate fuel is written right into the physics we already know.
Okay, so if the math checks out, why haven't we found one? Well, this is where we hit our first huge roadblock. Even if these things are out there, they'd pretty much be cosmic ghosts, completely and utterly invisible to us.
And the reason is simple. All that incredible energy in the core doesn't come out as light. It's almost entirely released as neutrinos, those tiny, ghostly particles that barely interact with anything. And even if we could build a detector good enough, the star's insane gravity would stretch their energy out so much, it's called redshift, that they just fade into the cosmic background noise. Any light trying to escape the surface would lose 99.9% of its energy on the way out.
The conclusion here is pretty blunt. When we talk about finding exotic objects, Electroweak stars get put in Tier 4. That means we should never ever expect to observe one, with any technology. Ever.
But honestly, being invisible is actually the lesser of its two problems. There's a much, much bigger issue. It looks like there's just no way for one of these stars to form in the first place. The idea is consistent, sure, but the path to get there seems completely blocked off. So in theory, the recipe would look something like this. A huge star collapses, it forms a neutron star, and then the core of that star gets crushed even more into a sort of soup of free quarks. But here's the make-or-break step. Something has to ignite that quark soup to that quadrillion-degree temperature to kick off the Electroweak burning.
And that's the showstopper, right there. According to every model we have of how stars live and die, there is just no known process that can get a stellar core that hot.
Long before it could ever hope to reach that ignition temperature, the crushing gravity would just win. It would collapse the whole thing straight into a black hole. Game over. The fuse is just too long, and gravity always wins that race.
So, where does this leave us? Well, it leaves us with this beautiful, mathematically perfect idea that just doesn't seem to connect with the universe we actually live in. It's a perfect case of physics on paper only.
And this is really what makes the Electroweak Star so different from other theoretical objects. We have ideas for things like dark stars or hybrid stars, and scientists have actual strategies for how we might go about finding them. But the Electroweak Star, the problem isn't that our telescopes are bad. The problem is the universe itself just doesn't seem to know how to make one. The evolutionary path is just wrong.
This fuel hierarchy really just puts it all into perspective, doesn't it? We've seen fusion, we've seen neutron degeneracy, check and check. Quark degeneracy? That's a real possibility. We think it might be out there. But electroweak burning? It's way down at the bottom, in a category all its own. Impossible. Not because the physics is wrong, but because the universe doesn't seem to provide any way to get there.
And this all leads to a really profound and kind of humbling takeaway. The standard model, our rulebook for reality, is so rich, so complex that it seems to contain descriptions for things that just can't be made in our cosmos. The laws for them exist, but the right ingredients or the right conditions are just missing.
And that just leaves us with this one last incredible thought to chew on. The Electroweak Star might just be a ghost in the machine, a mathematical oddity, but its story tells us something amazing. The laws of physics themselves might describe perfectly logical, incredible things that just can't exist here because our universe never built the factory that could make them. So what else, you have to wonder, is locked away on paper, just waiting for a universe that knows how to bring it to life?